Okay, so this video is a very common question that comes up in many GCSE papers that I've seen over the past year. So I think it'd be really useful if we go through this together. So we've got a circle at the centre 0, 0, and the tangent meets the circle at the point P equals 4, 3. And it's asking you to find an equation for the tangent to the circle. So you can see here that I've already formulated our equation for our circle. We've got the centre 0, 0, and our radius is 5, which makes r squared 25. So I've also wrote some key information that we're going to be using throughout this video. So you've got what the equation of a gradient is and our equation for a straight line. So on this drawing, you can see that I've already actually sketched what's going to be very important. So you can see that I've got this line here, which is obviously my radius, and it meets the tangent at a right angle. So therefore, it's perpendicular to our tangent. Okay, so what I want us to consider first is, can I find the gradient of this radius here? So can I find my gradient? Well, I know my gradient is given by the change in y divided by my change in x. Sorry, that's meant to say that. Okay, so my change in y here, well, I know this point is 4, 3, which means on the y-axis we have a change of 3, and on my x-axis I have a change of 4. So, in order to find my gradient of my radius, my change in y we said was 3, and my change in x is 4. Okay, I'm going to colour coordinate this as we go so we don't lose track of what we're doing. So this is the gradient of my red line, okay, my radius. So what I want us to think about now is what happens with our gradient of our perpendicular line. Well, if we know that my tangent is perpendicular to the radius, so tangent is perpendicular to the radius, okay, it meets at a right angle, then what do we know about its gradient? Well, we know that we have to flip the gradient upside down and we have to change its sign. Okay, so we flip the gradient and we change the sign. Okay, so what that means is that my gradient for my perpendicular line, so my tangent, is going to be 4 over 3. I flipped it, and at the minute it's a positive, so it's going to be a negative because I've changed the sign. So my tangent has a gradient of minus 4 over 3. I want us to consider now the fact that the tangent is a straight line, so it has the form y equals to mx plus c, as we can see above. You can see here that I've stated that m is my gradient and c is my y-intercept. Well, I already know that the tangent has a gradient of minus 4 over 3, so we can plug that in for m. Y equals minus 4 over 3x plus c. Our aim is now to find what c is. Okay, we don't know the value of c. Now, there's a real nifty trick that we can use in order to find what c is. And the way that we can do this is we're going to use this coordinate they've given us up here. We know that p is a point on that gradient. And what this means is that when y is equal to 3, the value of x is equal to 4. And if I simply substitute this in to what I got for my equation, I'll be able to find what c is. So let's do this together. We'll have 3 equals minus 4 over 3 times by 4 plus c. Okay, upon simplification, I'm going to get 3 is minus 16 over 3 plus c. And if I rearrange this, I get 3 plus 16 over 3 is equal to c. Now, I've got to add a whole number and a fraction. The nice way to do this is to write 3 as 9 over 3 plus 16 over 3, which is c. And this gives me an answer of c is equal to 25 over 3. We're literally at the stage now where we can write our equation for our tangent. And this is just by substituting our value of c into this equation down here. So we'll have y equals minus 4 over 3x plus 25 over 3. Okay, and this is my final answer. This is my equation of my tangent.